Healthcare interoperability fails not because standards don't exist, but because real hospital systems cannot easily speak those standards. Hospitals produce HL7 messages, insurers exchange CSV files, national exchanges like NHCX require FHIR APIs. Each new connection today becomes a custom integration project. We built the NHCX interoperability platform, a reusable adapter layer that accepts legacy healthcare data, normalizes it into a canonical healthcare model, enriches it using semantic intelligence, and generates standard compliant FHIR bundles across the workflows. I will demonstrate this using two real workflows: coverage eligibility and claims. Let's start with typical HL7 ADT message from a hospital system. This is the kind of data most hospitals already produce. This platform first selects the appropriate ingestion adapter using the strategy pattern. It then converts the HL7 message into a canonical eligibility model. The AI layer normalizes the demographics and enhances the clinical meaning. Finally, the eligibility FHIR builder generates a standards compliant FHIR bundle. Here we see patient, we see coverage, and we also see the condition which was normalized with integration with AI and Snowmed. Notice that no HL7 logic exists in the FHIR layer. The canonical model isolates message format from healthcare meaning. The conversion is generic and works for any version of HL7. Now, transitioning into claims. The platform automatically switches to a different ingestion adapter. It converts the CSV into a canonical claim model. Then the AI layer performs anomaly detection and semantic enrichment. Then the claim FHIR builder generates a FHIR claim resource. And this is the output for a claim which matches the FHIR standards. Notice as an architecture plus point, I want to mention that we did not rewrite the core system. We only added a new adapter and a new workflow builder. To show you, the first thing I want to show is the AI integration. As you can see, initially when we did the eligibility canonical model, the AI engine normalized patient demographics and clinical conditions, and then the normalized the condition of diabetes. Similarly, when we switched to the canonical model claims, the AI engine ran the claim anomaly detection, and then it detected a high value claim, CLM 9999. Now going back to the architecture, this is the architecture pipeline that we built. Any input source, whether it be a hospital or backend HL7 messages, CSV flat files, any future APIs, they can integrate with our platform. We pass the data through our pipeline, and then we output the FHIR bundle based on the FHIR standards. One other thing to mention here is whenever we have to add a new source for ingestion, all we need to do is add a new adapter. None of the existing code or existing core platform needs to change. We just need to add an adapter. Likewise, if we have to add a new canonical model. Right now we are doing eligibility and claims. All we need to do is add a new builder in the use case factory without touching any of the existing flow. So this is extremely extensible, follows these solid principles, and that is why we call this a platform. Now, just to close out my demo, few things I want to reiterate again. This is not a converter. It is a reusable interoperability middleware layer that enables legacy hospital systems to participate in standardized digital health ecosystem like NHCX without rewriting their existing systems. We built the missing middle layer in healthcare interoperability. For this demo, we focused on segments required for the eligibility and claims workflows. The important part is that our ingestion layer is segment agnostic and extensible. Adding support for additional segments only requires updating the adaptable logic. The canonical AI and FHIR layers remain unchanged. So scaling coverage does not require architecture changes. Thank you.